Hello, welcome to another episode of Excel Talk Show. So today we are going to continue the advent of code. Okay, continue the advent of code and problem number 3. Now, for a change, let's see how much problem I can solve today in an hour. Let's do that. So yesterday, just review. Yesterday we did Advent of Code, day 2, problem 2, and before that, problem 2, and before that, problem 1. So today we are going to continue to problem 3. Okay, Advent of Code, problem 3. And by the way, I'm on Odyssey, but I haven't really started to get used to it yet. So I'm on Odyssey, so you can see all my YouTube videos there. So where do I see it? Sync your channel. I'm afraid. Let's see analytics. Regular expressions. Most recent reviews, 35 followers. So I started to have some followers. Let's see. Home. Yeah, how do I get to my channels? It used to be this button, but now it says sync your channel. I'm not sure what that is. I wanted to show all my videos. Usually they auto sync. So anyway, Advent of Code number 3, okay? Let's do that. And I haven't read the problem yet. Well, I did a little bit yesterday, so let's see how far we can go. Hello, JR. So Advent of Code, let's begin, okay? Today, so let's start Wolfram language. Advent of Code in Wolfram language. Okay, let's see. There's already problem 12 or something released, so I'm kind of late. At this rate, we won't catch up, so I need to do much faster. Okay, start the Wolfram engine. Okay, number 3, okay, questions, comment, ask me, okay, that expose, I don't know about expose. So number 3, rucksack reorganization. Okay, one elf has an important job of loading all the rucksacks with supplies for jungle journey. Unfortunately, that elf didn't quite follow. Blah, blah, blah. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. Okay, so there's a bag, 2 compartments, or we can say 2 compartments of a bag, and there's a mistake. Okay, the elves have made a list of all the items currently in each rucksack. Okay, that's your puzzle input. But they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is A, and A refers to different type of items. Okay, lowercase and uppercase. So each character represents an item. Case matters. Okay, the list of items for each rucksack is given as characters or on a single line. Okay, one line has lots of characters. Each character represents an item. A given rucksack always has the same number of items in each of its 2 compartments. So that means the number of characters is even. So the first half of the characters represents items in the first compartments, while the second half of the characters represents item in the second compartment. Okay, for example, suppose you have the following list of contents from 6 rucksacks. Okay, copy that. That's the problem input. Okay, so let's see. Okay, so that's the input. Okay, so now it tries to explain further. So the first rucksack contains the items J, R, W, something, something, which means its first compartments contains the items that, up to R. Okay, and while the second compartment contains the items that, basically you split this string into two. It should be even. The only item type that appear in both compartments is lowercase p. Okay, now let's do some checking. Okay, so count the number of characters. There's 24 characters. You can see at the bottom, 24 characters. So the first half and second half. So each one is 12. Each compartment has 12 characters. Okay. And let's see, what about the case? So lowercase, wait, I don't know, wait, let's see. The second rucksack compartments contains that, okay, and that, okay. So JQHR, something, then SSL, okay. The only item type that appears in both compartments is uppercase L. Okay, so apparently there is a item that appears, there's a character that appears in the first half of the string and got repeated in the second half of the string. So far there's only one such case in each of these lines. Okay, the third rucksack compartments contain that and that. PMM, okay, that's the third one, okay, and the only common item is uppercase P, okay, here, P and P. Oh, okay, so in this case, both of them, wait, what? The third rucksack's compartments contain PMMD, so that's this one. So hold on a second, there are 3 capital P's here, okay? Now I don't know, now can you guys see it? Okay, so there are 3 capital P here, so an item has been repeated 3 times. So this is the third rucksack. Okay, so they divide that by 2 into 2 compartments. So the first compartment, the P is repeated. Okay, so a character may be repeated in one compartment, but the problem is trying to emphasize whether the item are in both compartments. Okay, so let's read further. The fourth rucksack's compartments only share item type V. Okay, that's the fourth one. It shares, wait, the fourth one, what? 1, 2, 3, the fourth one is this one, item V. So V is here, and also appear here and here and here. So it happens 4 times. But okay, so what is he talking about? I mean, while the second item set, the only item type that appears in both compartments. So that's what he is emphasizing. So if a letter repeats in one compartment, we don't care. But we really want to care if a letter happens in both. Okay, so that's the fourth rucksack. The fifth only share items T. Okay, T, okay, there's a lowercase t there, check. The sixth only share item type S, okay, so, okay, makes sense, so far so good. So each line is a sequence of characters, and the characters are supposed to be split into 2 parts, the first compartment and the second one. And what you want to find out, so far it's saying that you want to find out if an item are repeated that appears in both. So you want to find a character that appears in both, in the first part of the string and the second half of the string. That's correct. And case matters, okay? So to help prioritize item arrangement, rearrangement, every item type can be converted to a priority. Now, I'm a bit confused about his concept of item type. So do the characters represent an item type or is just an item? So let's see here. Lowercase a and capital case A refers to different types of items, okay? So it appears that each of the character represents a type of items. Maybe it doesn't matter. Okay, so it's a bit confusing, you know. I don't think the advent of code, their problem description is written in a perfect way. Anyway, so let's read on. To help prioritize item rearrangement, every item type can be converted to a priority, okay? Lowercase item types A through Z have priorities 1 to 26, and uppercase has priorities 27 to 52, okay? That's their priority, okay? So that means you probably need some kind of map. You know, you want to turn a character into its number, you know, one of the 1 to 52. Okay, in the above example, the priority of the item type that appears in both compartments of each rucksack is, okay, so yeah, so apparently in each line there is a character that's repeated. There exists one and only one character that is repeated in the first half of the line and the second half of the line, okay? And if you convert to, you can convert, you know, each of the character into a number, okay? And then, okay, then it says the sum of these is 157, okay? So apparently you need to sum them up, okay? Find the item type that appears in both compartments of each rucksack. Okay, what is the sum of the priorities of those item types? Okay, simple problem. A bit wordy, but problem should be simple. Hello, Greg and Doc. Okay, so let's summarize. So you are given a bunch of, you are given a string, which is several lines. In each line is a bunch of characters. Now you are supposed to divide this line into two parts, the first half and the second half. You know, the number of characters is always even, supposedly. Yeah, let's double check, okay? So okay, so this one, what? 32 characters, okay? 18 characters, okay? 30 even, correct? 16 even, correct? 24. So yeah, so each line, bunch of characters, you want to find a character that's repeated, that appears in both the first half and the second half. Once you find that, once you find that character, you want to change that character into a number. You know, 1 to 26 or 27 to 51. You want to turn that into a number, then sum it. You know, sum such a character in all these, and also it assumes that there is only one character that is repeated in first half and second half. You know, it does not, yeah, so it says that only one occurrence, okay? This is important because when it comes to efficiency, When you find that character, then that's repeated, you can stop. Otherwise, you have to go through again. So let's see, make sure that is the case. One elf important job, something, something, something. Unfortunately, something, 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 something. The elf that did the packing failed to follow this rule for exactly one item type. Okay, now this storytelling description of the problem is imprecise because, first of all, there's a confusion between item and item type. In here it mentions item type. It's not necessary. You can just say it's an item. People understand you have two same item. Well, okay, you might introduce type because if you have 2 bags of peanuts, so you want to use the type to indicate they are the same type. Okay, anyway, so item type. So there's basically, so each line there's just one character that's repeated in first half and second half. So so we need to find one. Easy. Okay, first of all, let's write a mathematical description. Given a string of lines, for each line there is a character that appears in both first half of the string and second half of the string. Find that character for each line. Change the character to a number, sum. Find the sum. Okay, that's a mathematical description of the problem instead of these verbosity. Okay, so that is a problem. So okay, so given a string, so you want to find first half. So let's start with a single line. Let's see how to work that out. Starting with a single line, you want the function that gives a bunch of string. First, so you want to find a character that is both in the first half. Okay, interesting problem. So this problem is a test of efficiency, because if you don't do it properly, your program will be very inefficient because it's going to involve combinatorial comparison. Okay, so there are many solutions to solve it. First of all, you divide the string into 2 parts. You want to find a character that appears in both. So there are so many ways to do it. So for example, one way is to you sort them. Then you just compare one by one. Well, yeah, you can sort them. Then no, you don't. Well, yeah, sort them first is one of the step you can do, but then you have to still go through. Then you can use binary search to see if a character is in the second one, but that gets complex. Okay, sorting is one thing. The other way is simply start with the first character in one part and go do a loop, check if that's in the second part of the string. If not, start with the second character in the first half, then do the same. Okay, so there are quite a few ways to do it. So there is always one character that repeats. So you have to think about this in order to come up with the most efficient, algorithmically efficient way. So I prefer to do that. That's how I usually code. So of course, I mean, the alternative is just start to code, just start to do a loop then. But I like to, my typical way of coding is to think about the problem first. So, okay, so let me think about it. It's gonna be boring for you guys, just skip. So there's only one character that repeats, and your job is to find that character. So, and then you can do character comparison one by one, or you could also use regular expression. Yeah, so this problem has a lot of solutions. The way you do a regular expression is that you just maybe use or. No, or actually you use A to Z and capital A to Z of a single. Yes, there's so many solutions. Apparently so many ways to approach, but the problem is to determine which one is the most efficient. Doesn't seem too obvious. So I think regular expression, you can use that, or you can just like hardcore character by character comparison. Which one is more efficient? You don't know, because sometimes regular expression, it automatically do the comparison, but you don't know if it's gonna be more efficient or not, because you also need to capture. You need to find out that letter, which one is repeat, not just that it repeats. You need to know which one. So okay, so actually I still need to think about this. So you can sort possible solutions, sort, and regular expression is also not sure. The sure way is just to compare character by character. So remember, there's only one such. There exists a character that's repeated, and only one of them. So you will always have such a letter. So let's just go through each character then. Oh God, there's so many ways to do this. Because if you simply go through each character, you also have inefficiency. Because once you did a comparison, then you know the second part do not. You know what that character is already. So okay, so back to sorting. Now if you sort them, you can then apply some kind of binary search. Start from the middle of this first part. No, okay. I don't know. Let's start to code it then. Okay, let's see this Wolfram language. Okay, so let's start to code X input. Okay, let's say X1. Okay, so that's a string. So first job is you want to divide it into two parts. So length at X1, then okay, so divide that. Okay, let's say ln. So that perhaps we need the length later. I don't know for sure, but so then xlen divided by 2 string take. Okay, that's probably x1. So that's the first half. let's say front, okay? I mean, the art of naming. Let's say pouch 1, okay? Pouch 1 and pouch 2. That's the first compartment and second compartment, okay? Then string tag. Okay, there are so many ways to do it actually. So do I want to, maybe we should turn the string. So one way is to turn a string into a list of characters. Yeah, in Wolfram language you have that advantage because you don't have to deal with strings. You can, each string can become a symbol, like a variable name. Then you just compare the equality of the symbol instead of comparison of the string equality. So many ways. So once you turn it into a list, then you have lots of tremendous number of functions that work on list, just like Lisp. So now let's look at the string take function. Right now I'm thinking what's the best way to split the string. Okay, so we can do this. Okay, let's repeat it. Okay, let's try that. It's just for the sake of trying. Let's see. What? X length. Oh, not length. You need string length in Wolfram language. Okay, so yeah. Let's put some clean up here. Good. Okay, so that is the why is it not WRH? Okay, you got error here, so this means this needs to be +1. Let's do it again. Okay, perfect. That's how you split the string into two parts. Now, for each character in string, yeah, let's see all string functions, okay? So this is how you see all string functions in Wolfram language. Technically, all functions that contains the word string. Okay, so let's see display string. So in string, we can do that. Now remember, Wolfram language is a very, very high level language. So almost for any algorithm, it already has a built-in function. Like you don't have to, there's a built-in function already. So, but if you are not careful, each of these functions are very costly. Each of these functions equals to 10 calling 10 functions in Python or Haskell. So you want to be very careful because otherwise it's very slow. So for example, there is the function inString. InString is a global object that is assigned to be the text of the nth input line. Okay, that's not what we want. String ends, string deletes, string counts, string contains. Okay, that's so you can use that, but if you use that in a loop, it's going to be very inefficient. So right now I'm thinking, should I just do whatever to come out with the answer, or should I think about the most efficient way, which is what I usually do. I don't want to, I don't like to just come out with an answer. That's because that if you do that, you lose the purpose of doing this exercise. You see, these are trivial programming toy problems. So the fun part is really get you to think, to know the language you are working on, to explore what is the most efficient way, what's the cost of each function you call or the construct, getting the properties or object if you are using object-oriented language. That's a key. That's a benefit. If you just want to solve the problem, that's not interesting. But of course, if you are new to the language, if you are a beginner in programming, yeah, you'll be happy you solved the problem. But so let's go back to this. Let's see. Let me think about what to do the best. String break, bytecount, string cases. Okay. String cases give a list of substring that matches the string expression pattern. Okay, so let me think again. If we go the brute force way, which we start with a character, do a loop, go through the second half of the string to see if it's there. Okay, this is the most brute force way. And if you find it, if you do this in most languages, especially low-level languages, this is the most efficient way. But that does not apply to Wolfram language, because if you do Wolfram language in general, the more function you call, the more expensive it becomes, because each of the function is very high level. You want to make your code call the least number of functions, including in a loop. And in general, you don't want to do loop at all. So, you guys know what I'm saying. I think this video is mostly just me talking to myself. What is the best way to describing solving a problem? Grunt style. I don't know what is a grunt style. Or atomically, simply, without any predefined functions. You cannot, so what is grunt style? Explain. And in general, you cannot have a solution without calling any predefined functions. What do you mean? Assembly language. Is that what grunt style mean? I don't know. Explain, okay? Okay, so string count, string contains we can use for sure. That checks a pattern. Now, does it return though? No, so string cases. So string contains, returns either true or false of a pattern. That's not what we want, because we need to know exactly which is the character that matches. Okay, so we cannot use string contains now, but we can use string cases. String pattern give a list of the substrings in string that matches the string expression pattern. Okay, I think this is what we are going to use, because this, if you call this, you just give it one single call, one single function call, no loop involved, because the algorithm, the function will do the algorithm for you. So yeah, I think that's the one we want. Okay, let's try this one. String contains, okay, x1. Wait, it needs to be the second part. Okay, x pouch contains the then x pouch 1. Okay, but here it needs to be a pattern. Okay, not just, let's see if it works. Let's go to my Wolfram language tutorial, copy, paste, and put the link here. Okay, today's talk show, Wolfram language tutorial. We are working with strings, and we are working with string patterns. Now in Wolfram language, there are two string patterns. One is regular expression. The other one is string expression. They are essentially regular expression, but with a different syntax. Okay. So now remember, we need to get the character, not just true or false. We need to get the character. So let's see. Normally in a regular expression, how do you string cases? Okay. So let's go back to the code. Not strings, string cases. Okay. Okay, I think I know what to do. String cases pattern. Okay, so string cases, the pattern needs to be actually multiple patterns. So the result will be one single line, two function calls in Wolfram language. The solution will just be one single, almost one single line. Now we need to represent a pattern. Yeah, and also we need to say 1, limit to 1, because otherwise it's gonna continue searching. So includes only the first n substrings of that match. Okay, again, there are so many ways to do this. Okay, but we do need 1 for sure. That means tell it to stop when it found 1. Because we know there's only one character that repeats according to the spec. And then now so now we need to represent the pattern expression. Okay, so here is regular expression, but you also have Okay, I don't know. So let's try this. Okay. Regular expression. Okay. So here okay, create a regular expression, and here will be that, and join string, string join, we need to join string. Let's use let's use a form that it's easy to understand, okay, but more cumbersome. So here we want to add, okay, this is a regular expression for any of these characters, okay, and you need to plus one, wait, one single character, okay, one single character, and okay, so let's see what it does now. There it is, supreme. Supreme. One single line, one shot solution. So now that's one single character. You need to turn that character into a number, okay? So we need to construct a map. Lowercase a to z is mapped to 1 to 26, and uppercase a to z is mapped to 27 to 52. Is that right? There it is. That's correct. Okay, so let's construct the map. Okay, turn characters to numbers. Okay, there's probably a built-in function. Okay, there's probably a built-in function. Let's see. String Q, string repeat, string replace, string table. So I think the name might be to string to integer string. What is that? Integer string gives a string consisting of the decimal digits. Okay, now remember, we need a function that takes a character into a number, and 1 to 6 or 1 to 26 or 27 to 52. Okay, now one way to do that is to change each strings to their code point, Unicode code point, ASCII code point. Okay, because let's see, printable ASCII. Okay, that's not what we want. Let's see, Unicode. Okay, code point. Let's see, 2-character code. Okay, so for example, there's this 2-character code. Let me show you an example. So here you give it a string. Let's say lowercase a, that would be 97, I think, or maybe it's capital A. Let's see. See, lowercase a is 97. So you just minus whatever, minus 97, minus 96. So for each character, we can do that. Yeah, so actually this is a good solution. Okay, copy that. So let's write full document, so you guys can understand Wolfram language. I mean, so let's say char to num. Okay, so you can understand what I'm doing. Normally I would just write it without, with anonymous function. Okay, so x is a string, okay, then you just turn that, let's say char, okay, so it's easier to understand. So that in minus 96, okay, that's, yeah, so a becomes 1, okay. Now let's try capital A. Let's see what is that. Okay, 65. Oh yeah, but they are this is no good. This approach, if you do this, you cannot, depends on lowercase or uppercase, you have to do different, you have to minus a different number. It's because it's that way because of the ASCII. Because of the ASCII table, they have a bunch of punctuations between the lowercase letters and the capital case letters. You can see here. So you can see here's a capital case. They start with 65, and so on. Then you can see here is a bunch of punctuations. So that becomes 91, 92, and blah, blah, blah. Then you have lowercase, okay? So can we make this turning a character to a number without using a if statement? When you code, it's in many math problems you can avoid the if statement, because in mathematics usually you don't want if statement. You don't want, depends on which case, then that's not math. Usually you turn things into numbers and apply one single function, such as modular arithmetics. We did yesterday. Yesterday the problem is a good example. You don't do if statement, condition, if this, check this, you simply use modular arithmetics. There's no if statements, everything works out for the whole case. So similarly, we want to try to do that. Okay, so but can we do that? That's the question. So capital case and lowercase a, capital case and lowercase a, is there a way to know to turn it into a number without using if statement? Well, you can turn into a number, and if the number is greater than certain number, you add 10 or something. Yeah, but that's still a if statement. Okay, do you guys see what I'm saying? So what you can do is something like that. If, okay, if this is greater than 27, then you minus like 1, 2, 3, 4, 5, 6. Okay, then you do that and minus 6. Otherwise, just return that x or whatever. So, but if you do this, yeah, sure. But you got a conditional. You got conditional. So, oh God, when you think about efficient, yeah, that's probably the most efficient. Is there any other way? Because otherwise, you just create a hash table. A maps to a number, B maps to a number, a hash table. That is actually not efficient, because here all you have to do is one single if statement. But if you use hash table, that's for each character you have to find the bucket. Okay, so we are just, so which way to go? So let's just do this, okay? Let's see if this works. Okay, so then okay, let's say A, okay, then we need to God, we need to make this correct. Okay, so x equals true. Six 65 actually minus 65. Okay, so if x equals to something like that, probably incorrect, but okay, here's a whole code. It's probably incorrect. Let's think about it. Now we can either just try it, start to trial and error, or actually think about this, then one shot it will be correct. So let's do the one shot correct. So two character code is gonna be if it's capital A, you minus not 65 minus 64. Okay, now if it's lowercase a, so you got 97 minus 64, 97 minus 64, 97, you got 23. Oh wait, there is more complexity, because in this problem the lower case has smaller numbers, the uppercase has larger numbers. Yeah, so this algorithm is not gonna work, or it's going to be more complex. And also, if you use this algorithm, there is somewhat inelegant, because you have this magical two-character code, according to the ASCII standard. Y, for example, Y is A65. Well, there's no logical reason except historical reason. Capital A is 65. Y is lowercase. So this ASCII code is a historical reason, and if you use that ASCII table, your code becomes dependent on some historical thing. So if you judge your code by elegance, then it's kind of problematic, because the ASCII code is not part of mathematics. Do you guys see what I'm saying? The ASCII code is just, that's why programmers and mathematicians, usually their thinking, their ways are very different. Programmers will love to use ASCII code, especially the C++, Unix people. They love to use it. They use it right away without thinking. They think this would be great, this would be clever, this would be, very fast too, because every language is built upon ASCII character code. But from a mathematician's perspective, what the fuck is ASCII code? That's just arbitrary historical thing. Your mathematical formulas does not refer to some human created complexity. So that's why. So there are trade-off here in terms of how you judge the code. You can use, you can kind of do a clever hack using ASCII code, or you can, well, the other way is just to create a hash table, then actual table. So, but I mean, so in either case, I mean, even if you use ASCII code, you have to do more than one if statement. Or you can check whether it's uppercase. Okay, first of all, let's write some code just to solve this problem. Okay, let's not worry about too many things. So to solve this problem is just, first of all, you check the letter case. Easiest way. Okay, so so is there a function that checks uppercase? There it is. To uppercase Q, okay. Then you have lowercase. Fuck. So you have lowercase q that returns true or false. So let's do this. Okay, so let's write this. If uppercase char, then that, else that. Okay, hope this is clear. Okay, if it's uppercase, then let's see the ASCII code. Uppercase, yeah, minus 64. Okay, now if it's lowercase, otherwise, if it's lowercase, then minus 96. Okay. Okay, so that works. Okay, let's remove the other. This is, not optimal because the if statement is ugly. And then you have to use uppercase, lowercase. Then okay, let's whatever. Let's just do it. Okay. Test. Okay, incorrect. Oh yeah, of course, obviously. Minus 96. If it's uppercase, minus 64 plus 26. Okay, that's actually that. So, well, there. Okay, we can rewrite this. So if you rewrite the function this way, you don't have pattern matching, which is much faster. But then the function, so the function currently take one single character at a time. So you need to, for every character, you need to call this function. The other alternative is that you can make this function takes a string, and then in that case you'll return a bunch of numbers. Okay, no, we don't. We want a single. Yeah, okay. String cases. Then all you have to do. Okay, let's put this function here. Okay. Then string cases. Then let's just map chart to number, map to this thing. Okay, let's see x2. Okay, okay. Let's see how it goes. P is 16. Is that correct? I don't know. So let's try a different. Yeah, P is 16. That's correct. Now let's try the second line. Okay. Copy that. Paste. Evaluate it. L is 38. Correct. So here's a solution. You see 16, 38, 42, 22. Okay, then let's try the next line. Run it. 42. Correct. So far so good. Now let's just try the whole thing. Okay, looks like we are on the right track. We are on the right track. So now here is the input. Let's say so there is the x, there's the input, and here is our function. Then test, ignore it. Then we want to split the input into a bunch of strings. Okay, so what we can do is split string, split string, string split. Okay, split by a single line. That's correct. Once you split that, we got a list. Okay, let's say lines. Okay, so we got a bunch of lines. It's okay, we got a bunch of lines, and the length, well, we don't want all that, too many. So let's see. Yeah, but we want it to be efficient. Okay, so in fact we can call a string partition, so a lot of Wolfram specific functions. String partition, we are just split a string into two substrings. Okay, so you can see, so we don't need to manually do the pouch 1, pouch 2. Okay, so string partition, and we don't need to even calculate the length anymore. Okay, string partition, split a string into a list of strings, 2 of them. Oh wait, oh yeah, so you have to have length here. So string length, wait, we need to work on a single line, so hold on a second. So that's lines. You want to apply the partition to a string. So Okay, map a function to lines. What is a function? The function is here. Okay, string partition length. Yeah, so there, this is a function. Okay, so what this means is that you map a function to a list of lines. Okay, so here, so string split, so let's do that. We don't even need that. So this will first, so let me explain this one. Okay, so map text to arguments. The first one is a function, the second one is the input, then you split it, so you got a list of lines. Now, so this function applies to each line of a string, and this sharp sign, number sign, means the argument. So you take the argument and you also compute the length, then you partition it, so it should return 2. So for example, let me show you. Okay, so anyway, we will show it. Okay, we'll run it. So what this will come out is a list of things, and each thing is a list of 2 parts, a list of 2 strings. One is the front of the string and end of the string. Okay, so actually let's show that so you can see. Wait, where is it? Delete partition. What? I think I'm going too slow, but so no, the partition failed. Let's try again. Okay, so let me show this. The partition failed. Let's try. Oh, you forgot to divide by 2. Fucking idiotic. Of course, you need to string length divided by 2. Okay, so now there it is. Okay, that's the then you can do this. Yeah. So now you can clearly see each line is split into 2 parts. Okay, so that is the result of that. Now what we have to do is we string cases. Okay, so then we do this. We want to again map a function to each of the line. Now this line is now a list of 2 strings. Okay, so again you do a map. 2 things. The first part is this thing. Okay, I don't know if I can. This is, the code is getting complex, but so here now the first part needs to be a function. Okay, the function will be this. Okay, basically. Okay, let's do that. Okay, the function in case is pouch 1, pouch 2. So this will be arguments, second elements. Okay, well actually let's just say last last part. Pouch 1 is the first part, okay? Fantastic. I think our code is getting fantastic. Okay, let me show you. There it is. PLPVTS. PLPVTS. Okay, now all you have to do is just map them. It's so easy. So again, you need a map. Okay, again you need a map. And the second part, now you see the nature of Lisp. This is how you see the nature of the heavily nested syntax. Now, normally people don't code Wolfram language in this way, too much nesting, but I'm trying to avoid the shortcut syntax, because you don't because that requires memorization and it's hard to understand if you don't have the experience. So anyway, now we map just this char to number. Yeah, each one is just a number. Okay, we map and give it a. Okay, I think that's that. We map it to level 2. That's what this means. Okay, let's see. Level 2. Okay, we got. Then can we do total? Let's see. Fantastic. One-shot coding solution. So the solution is 2 lines, but I can shorten it much. I can make it 1 line. You see, here is just a function. So this part, you just put that there. It becomes 1 single line, and then all you have to do is you change the this code into a shortcut syntax, so it's much more condensed and in fact more readable. So yeah, let's do that. Okay. For example, if you change this, if you use an anonymous function, then you don't have the name char to number, so it's hard to understand. So anyway, so that's the solution. Let's move on. Okay, let's get my personal input. Let's see how huge it is. Okay, huge. Fine. Okay, select all, copy. Now let's go to talk show. Open it. Okay, and let's open a new buffer. Now save this AOC. Let's see, day 3, I think. Okay, drop to diet. Turn space to low line. Okay, now open it. And actually rename. Okay, that, yeah, so reopen it. That's your input. Okay, copy that, close. Actually open, copy the link file path and linkify there. Okay, now open it, copy it, close, back to the Wolfram language, and we can just paste it there. That's our whole input. Copy it, back here, paste, eval. Oh, what's the result? We forgot the total. Okay, let's add the total here. Okay, so let's see. X list equals to that. Okay. Total X list. Okay, 7581. Let's submit. I'm 99.999% is correct. That's the right answer. You are 1 gold star closer to collecting enough star fruit. Okay. Continue to part 2. Okay. Who is watching? Probably nobody. Let's see. 5. Oh, 6. Oh, God. We got some people watching. Say hi, okay? Say hi. Okay, let's get back. So, back to the code. We want to finish this coding problem. Advent of code, day 3. Okay? Now, let's, before we go on, let's clean up the code so that so for example, this part, just copy it. You know, Wolfram language has automatic formatting. So if you look at the code, you can see they indent your code depending on your window width automatically. You know, you don't even have to call a command to, it's like on the fly. So that's why, in my last few videos, I've complained about the industry's programmers' idiocy about their, formatting and coding style. You see? So that is represent, this part. Okay, so. And now I want to clean the code, okay, because that's usually you don't write that. Usually you let me show you. Okay, so I'm going to transform this code into something else. Let me show you. Okay, so so actually you need that part. Okay, okay. Okay, map at, and here is another map. Okay, now it's much simpler. And then this chart to num, let's also reduce it into some okay, so this okay, so the second part is equivalent to the first one. Let's see. So of course the 64 plus 26 minus 64 plus 26, we can combine that into one number, but let's leave it. Okay, I think that's it. So this part, let's just comment it out and comment it out. Okay, let's do it again. 7581. Okay, that's correct. Now let's remove that. Okay, put back the original. Let's go to God, I hope I don't mess up. Let's go back to original problem. What's the original problem's input? Do we have it here? Oh, there. Okay, that's good. Original problem's input. Okay, pop it back. Refresh. Make it color, syntax colored. So here is today's talk show, the problem number 1, and the solution is just this single line. Okay, well, actually you need to put the total together. That's the solution. Okay, Wolfram language. Okay, part 2 then. So it's now been 90 minutes. Not too bad. Because when you do, I have to talk. So if I do this by myself, it's probably 30 minutes. Yeah, well, 20 minutes if we 10-20 minutes if we go by speed, because then I don't have to worry about which algorithm to use and explain at every step. Okay, part 2. Let's finish this. As you finish identifying the misplaced items, the elves comes to you with another issue. For safety, the elves are divided. For safety, what the fucking word? For safety, the elves are divided into groups of 3. Okay, every elf carries a badge that identifies their group. Okay, for efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. A bit somewhat confusing. So are you talking about, so is the badge now a food item? Is the badge considered a food item in the pouch, in the compartments? Because previously the items in the rucksack are food, supposedly, then types of food. But now it says the badge is the only item type carried by all 3 elves. So are you talking about in the rucksack or not? So that is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksacks. Then all 3 elves will have item type B somewhere in their rucksacks. Okay, and at most 2 of the elves will be carrying any other item type. So if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack. So each elf carries a rucksack. Okay, so if group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack. And at most 2 of the elves will be carrying any other item type. What? Fucking illogical description. This advent of code description is not very good. Because here the problem is, first of all, the item type. First of all, there's a confusion between item versus item type. The type is not really necessary, but let's assume they introduce the type concept so that we can clarify, 2 bags of peanuts are different, so we can say they are the same type. Anyway, it's confusing. They shouldn't introduce type. But now, You see, before they are talking about food, you see, one elf has the important job of loading all of the rucksacks with supplies for the jungle journey. Supplies, okay? Now they are talking about badges in the rucksack. Badges are not supplies. What the fucking fuck? Okay, I'm ranting and bitching. This is just not well done. And given that I suppose they got a lot of sponsors, it becomes fairly popular. Quite a lot of sponsors. But the problem is not professionally written. Yeah, it tries to sell Christianity, which is fine, but the problem is not professionally written. At least to a mathematician, probably to most programmers, you don't care. That's my complaint. Most programmers, they don't see the details of things. When they don't analyze, typically the most programmers, they just start to code it, like trial and error. But to a mathematician, the problem is problematic. Okay, so now they are talking about badge. They are talking about badge, and each elf, so you have a bunch of elves, each elf has a badge. The elves are grouped into threes, so every 3 elf is one group, and they carry the group's badge. And this badge is apparently it's the only item type carried by all 3 elves. Oh, okay. So every 3 elf in a group, they have a badge, which is a item you put in the rucksack. But there's only one of it. Not a badge for every elf, but one badge for a group of 3 elves. So what? Wait. Look at the way they phrase, then all 3 elves will have item type B somewhere in their rucksack. And at most 2 of the elves will be carrying any other item type. What other fucking other item? Idiotic fuck. If a group's badge is item type B, so now there's another, it's so badly phrased. So now you are saying, before these items are food or supplies, but now you are saying one of the character in the input is a badge. That's what you are saying. And confusingly, it uses the letter B. So like B stand for badge. Very idiotic. Okay, so the problem is that someone forgot to put this year's updated authenticity sticker on the badges. Oh god, another concept. Authenticity sticker on the badge. All of the badges needs to be pulled out of the rucksacks so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. Okay, very corrupted. Very, how do you say? Very fucked up writing. So right now they are saying, these supplies, the item types. Again, you see, they are saying a badge is an item type, basically. Okay, and nobody wrote down which item type correspond to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves. Okay, so it looks like they are trying to, each line is a string. They are trying to find, I almost get the problem. They are trying to find a repeating character, a single character that repeats. So, remember before the input is a list of lines. So now essentially you are trying to partition the lines into groups of 3, where the group shares one single character. That's what probably. So now it comes here. Every set of 3 lines in your list corresponds to a single group. Okay, but each group can have a different badge item type. Yeah, of course. Shut up. So in above example, the first group is rucksacks are the first 3 lines. Okay. Okay, and the second group, rucksack, are the next 3 lines. Okay, apparently the group is already ordered. Right, so it's already like 3, ordered 3 group, So your job, I guess, is to find that item. I mean, the character that represents the badge. The item type that is a supply, but represent the badge. The fucking idiotic fuck. The unprofessional writing, the problems, stupid. Okay, so second group. So in the first group, the only item type that appears in all 3 rucksacks is lowercase r. So there you see, they are trying. The problem is for you to find a character for each 3 lines in that order, in a given order. There's a character that appears in each of the line, and your job is to identify it. The fucking stupid the story, fucking types and badge and elves, fuck, unprofessionally written story. And the problem is simply identify the letter that appears in each 3 consecutive 3 lines. Okay, in the second group, their badge item type must be Z, because Z appears in each and every of these 3 lines. Let's see. Capital Z, there it is. Capital Z, there it is. Capital Z, but here it appears twice. Okay, priorities for this item must still be found to organize their sticker attachment. Fucking introduce another concept, stickers. Why do they introduce the concept of stickers? Because not to help describe the problem, but to help to describe the story so that it somewhat makes sense. It already doesn't, because supply types, now your badge becomes a supply item type. It all doesn't make sense. You have a rucksack, you have 2 compartments, they are supplies, but now one of the supplies is a badge. But normally in a real world, a badge represents each elf has 1 badge, each person has 1 badge. So but now it's like 3 elves have 1 single badge, and this badge only appears in one of these 3 elves' bag, rucksack. It's not like real. It doesn't make a common sense. Stupid writing. This is my problem with this. And my problem is not just with, you see, my problem, this is a common problem of me framing the typical industrial programmers. The problem is that this story, this description of the problem is not well done. Okay, for example, the problem number 3, it applies to problem number 2 and day 1 too, but problem number 3 part 2 in particular, okay, very confusing. So the description of problem is not well done. But the problem is, you will find not a single programmer that criticizes this. Not a single one. The fucking industrial programmers, the common fuckheads. And when I do, like right now, I describe what's the problem, what's wrong with the writing. they'll start to call you a troll because they don't know. That's the problem. The more it's like typically, the more I look into detail, the more problem I find. But the insulting thing is that no other programmer see it. You'll find like 0 people criticizing the description of the problem. But when you do criticize, they'll say, "Oh, where's your code? Oh, you please suppose open source." Fucking idiots. So the problem now is, actually just to identify that letter common in every 3 lines. Okay, seems like. In the second group, their badge item type must be Z. Okay, and I suppose there's only one letter that has this property, appear in all 3 lines. Yeah, seems to be. Okay. So priorities, they, organize the sticker, which is non-concept, attachment efforts. Here they are 18. They are 18R for the first group. So then again, you have to convert the letters to the number and sum the number. You see, this is another stupidity of the problem. Because you see, in order to try, why do they want to turn the number? Why do they want to turn the character into a number? Why can't you, for example, the first solution, why can't you just say, find the sequence of letters? But instead, they want the number. Why? Because if you have a number, that helps the solution. That makes it easier to say, just one single number. So in order to do that, so they introduced in the story, in the description of the problem, introduced this kind of thing. Well, that's, you could say that adds extra step to the problem. Okay. So you convert the character into a number and sum them up. Okay. Find the item type that corresponds to the badges of each 3-elf group. What is the sum of the priorities of the 2 item types? Of those item types. Okay, easy. Okay, so now copy the code and let's do a problem 2. Okay. Problem 2. Okay, and okay, let's get elaborate. Okay, that's a code, but before we do that, let's get into okay, and same thing with problem 1. You'll see what I'm doing in a moment. Okay, show in browser. So today's talk show, problem 1, description, input, solution. Okay, and we are dealing with problem 2 now. Okay, so now let's start to code. So problem 2 is you want to group each 3 of them. Easy. Okay, very easy. Okay, let's just start to code. So first of all, okay, so input. Let's just write code. Okay. String split x input. Okay. Let's just define a bunch of variables so it's easier to understand the code. Okay, so now you have a list of strings, then you want to partition Okay. You don't need to split to front and back anymore. So actually, you partition into 3. Okay. So yeah. So string length x1 divided by 3. You want to partition into groups of 3. Okay. So let's do this. Okay, so wait. Partition x1 by x1 divided by, actually not divided by 3, just 3. Partition into each 3 of them. Okay. And in fact, we can do it. You can just try it. Let's show. Okay. So you can see the result. Okay, I typed it wrong. Not partial D. Partition. Okay. You see? So here's one group of 3. Here's a second group of 3. Okay? So now you have a list of lists. Each sublist is 3 strings. Okay? Now you want to map a function that takes a list of 3 strings, want to find a letter that's common in them all. Okay, interesting problem. Sam says, will you be documenting your solution on your website with an expansion? No. So Sam's question, because I have Xa Talk show, so each day's solution is already there. So your question is whether can I document it in detail? Nah, that takes too much time, because I already, if you watch my live stream, it's kind of slow, but you can fast forward. I explain in detail how everything works. And Wolfram language, I have a full tutorial, as you know, if you watch my video. So, and Wolfram language has full documentation, so you can look up. So I'm not going to do that. But let's solve this problem. Interesting problem. Interesting problem. Because now it wants to day 3. Yeah, day 3 problem 2. Now you want to, for each 3 strings, you want to find a letter that's common in all 3. Okay, there must be one single Wolfram language function that do that, I think. Possibly. Let's see. So you have a group, you have a list of things. You want to find a character that appears in all 3. So in other languages, low-level languages, Golang, JavaScript, Python, you basically start to do a loop. You go through each character and check if that character is in the 2nd string and whether it's in 3rd string. If so, stop. You found it. Okay, that's typically low-level language. In Wolfram language, you can do that as well. You can do that, but usually there is one built-in function that declaratively just give you the answer. So, but the trick is to you need to be familiar with Wolfram language. So you need to think what is that function's name would be. So I have to think about that. So you want a list of things you want to find that's common. You want to find an item that's common in all. Okay. That's an interesting problem. String rifle is string to list. No, it's a list to string. Okay, that's not what we want. We want some kind of combinatorial exist, something like exist, or let's see if there's such a function. String position. String difference, maybe string difference. Yeah, string difference. Is there a string difference? String intersection, okay? Let's try. There it is. Now, is there a string intersection? No, but you can turn a string into a sequence of symbols. Then this will work. Let me show you. Okay. So you have a list 1, let's say list 2, let's say list 3. Let's say A, B, C, okay? Let's say B, Z, H, okay? And let's say you need a B here too, so let's say whatever. Let's say H and B, okay? There it is. That is what you want. So in order to use this intersection function, each of the item is a symbol. So what you have to do is you can turn the string, each character, into a symbol, or in fact, it would be nice to turn them into a number first, using this number, because in the end you want the numbers anyway. So fantastic, let's do that. So first of all, turn the input into okay, so yeah, intersection is what we want. Sam says rejects uncommon frequency count. That might work, but needs some work. Yeah, so intersection would be a good. You see, that's it's kind of the nature of Wolfram language. When you code Wolfram language, you want to find a built-in function that kind of do what you need. Because in this case, typically just about in every programming language, you just do a loop, go through each character and check if it's in the other two. If you find it, stop. So you write a loop yourself. You can do that exactly in Wolfram language, but if you do that, your result is actually going to be slower. Okay, slower in Wolfram language. But if you use this, some kind of built-in, it's shorter and much faster as well. Because the actual algorithm, how does it do intersection anyway? You can sort it first, then you can maybe do binary search in many ways. Intersection can take 1,000 lists, so it automatically figure out, again by algorithm, to decide on which algorithm to use. So yeah, so anyway, so the built-in functions, they have a lot of power. So anyway, so in order to use that, we need to turn the numbers into either symbols or a list of characters. So let's see what functions do we have for characters. Okay, so there's a characteristic, character name, characters. Okay, character string gives a list of characters in a string. Fantastic, that's what we want. Okay, so instead of a string becomes a list of characters. Now once we have a list of characters, we can use intersection. Okay, so partition, so you want to turn to them into x3 equals to character. Okay, needs to be so you need to map this actually. Map, I'm gonna just use shortcut. Okay, map the x2 partition. Now last time the result is okay, so the last result is the result is like that. Okay, so actually I know what to do. Map to level -1. That means map to each of the atom, which is a string. Okay, so you want to map a function to x2, and what this function, the function is going to be just character. Okay. Okay, let me show you how that works so far. Okay, that doesn't work because you see it applies, but why is it not work? What is the character? Oh, you have two characters. You have to say S, I think. Yeah, characters, not character. Okay. Copy that back here. Paste eval. Fantastic. Then now all you have to do is say intersection. Not interval. Okay, then again you need a map. Okay, map something to x3. Then you need a function. Function is just intersection, and in this case you need to map to level 2. So let me see. So the input will be a list of characters. So you need to map to level 1. No, level 2 is correct. Okay, let's just do that. Let's say x4. What? Okay, let's say x4 equals to, okay, copy, copy. No, it did not return the right answer, did it? Let's try again. Let's try on this single. What? Oh, intersection needs different arguments. Okay, I know what to do. So instead of that, you need that. That's apply, okay? That's a shortcut. The add is a shortcut for the apply. There it is, okay? So this R is the first 3 lines, okay? So now we just modify this intersection into. Okay, you probably don't know what I'm doing, but that's let me explain that, okay? So here is a solution. Okay, so you got something wrong. Wait. Okay. Oh yeah, so you want to apply to level 1, okay? So let's try again. Okay, so R and Z, the original sample input, the result is R and Z. Then all you have to do now is just turn each the letter into a number and sum it up, okay? So now, but this part is interesting. I'm gonna copy, screenshot it, and that's the advent, the solution for advent of code day 3. It would be fun, you know, dramatic. So now we almost done, okay? So yeah, so what we have to do now is x5 is just convert it to this function map to what did we get? Oh, okay, we need the level, okay? So map 3 arguments. You want to map a function, this function. You want to map to x4, which is a list, which is this thing, and you want to map to level 2, okay? So here is the solution, okay? Let's do it again. Oh, then you need to total it up. Okay, total. So let's say x6 equals to total x5. Okay, 70. Now is that the correct answer? 70, correct. All we have to do now is to use our previous input. Okay, now pop this back. So wait, clean up. We don't need that. You don't need that. Okay, that's the, yeah. So pop this back and copy the original input and okay, so paste that there. Paste. Okay, that's a huge input, and now let's add semicolon so it suppresses the intermediate output, because otherwise you're gonna have a huge list of things. Okay, suppress the intermediate output. Just give me the total, my friend. 25, 25. Okay, let's submit without blink of an eye. We did this for 2 hours. Submit. That's the right answer, my friend. Day 3, Advent of Code, Day 3, passed. 2 problems in day 3, both passed. Now let's syntax color the Emacs buffer showing browser. Here is today's solution. Here is Wolfram solution to advent of code number 1. One single line. And here is the solution to advent of code number day 3, problem 2. Also one single line. You just combine those, remove those variables. It's one single line. And what is interesting is that we use the intersection function. Now, actually, can you do that in other languages? Oh, actually, you can. Yes, in other languages, you can. There is also intersection in Python. Intersection, the function intersection is in Wolfram language since 1990. Okay, 30 something years ago. But the intersection is added to Python in the past 10 years, 5 or 10. And some other language still, still don't have it, like C, and so anyway, so yeah, high level math, high level programming language. Okay, so that solves the problem. I'm happy and I'm tired. I need to get up and walk. Any comments? We shut down in 3 minutes. So random chat now. How do you get your command log mod output to another window? Okay, so Emacs command log mod, which I'm using, which is I modified a little bit, just a few lines. So let's show you. Okay, so you can see I'm calling the command source.command log, and you can see the source code, which is just here. So so I'm using the package command log mod. That's a package. Okay, that's open source. You can find it on Melpa. So let's open that file. So can we open that file? There it is. So it's by 2004 by who did it first? So the original guy is Michael Weber, I guess. Oh, folder.org. He's famous for wait, did I mix him up with someone else? Free dictionary, no, that's not. I forgot this is him or not. I guess, this is old page. This is like, there's a free online dictionary focused on functional programming. I don't know if that still exists or not. Anyway, so he wrote that in 2004 initially. So anyway, this is the command log mod, but it's problematic, so, and it's hard to start. It's kind of confusing, but if you read the detail, you'll know. Okay, so yeah, here's my explanation. So first of all, you have to do that. Then you want global, you do that. Then you have to call this to show the log buffer. So okay, so for example, let's close it. Yes. Do you want to save? No. Okay, so what I do is I open a new window, then say start command log mod, and that becomes that. Okay, so let me show you the code again. So you can find this in my, do I have it somewhere? No, I don't have it online. So you just copy my screenshot. Okay, just do it. Thank you guys for watching. Pay me. Okay, if you enjoyed, if you enjoyed my talk and enjoyed my tutorials, pay me $5, $20. Consider it as a service, like a coffee. Okay, bye guys.